So thanks for coming, everybody. And my name is Mitch. And I've been going around the world teaching people how to solder and how to make cool things with electronics for the last many years. I love doing this. And I wish I could have given you all the parts for free, but like I was saying, they cost me money, so I have to charge for it. I don't make any money from these workshops, though. I just make enough from those kits to pay for the workshop. So I make a living from these keychains that turn TVs off in public places called TV Be Gone. We are all going to make one of these today. This is actually a very, very easy project to understand and to make. And if you can understand this and make this, then you can make pretty much anything. Okay? So, but not only is it a great way to learn electronics, but it's a great thing for yourself and all of humanity. Because when a TV turns on, people just turn off, they just stare and drool and sit there for hours as their life goes away, as they're being programmed to buy stuff they don't want or need, including political candidates. So I make TV Be Gone as a tool so that people can choose the media in their life. And but anyways, that's how I make a living. I didn't choose to make a living doing that. It just sort of happened because life is actually kind of strange. Maybe you've noticed. I made TV Be Gone because I wanted one. I'm a TV addict. I'm a TV addict. And I went cold turkey. I'm no longer a user. But they started popping up all over in public places, and I didn't want that. So I was asking people, can you please turn that fucking thing off? And people would look at me like I'm from Mars. I'm kind of used to that. But I got tired of that, so I just made a remote control to turn them all off. And it turned out that other people wanted them too. And when my friends wanted them, and my friends' friends, and my friends' friends all wanted them, I figured it might be an opportunity. So I made a bunch, and I sold 20,000 in 3 weeks, and it's the only way I've made any money since 2004. It's kind of taken over my life. But these are the kind of things that happen if you explore and then do things you actually love. Opportunities present themselves that you wouldn't notice if you were working some stupid job you don't even like, because you come home from that stupid job you don't even like totally exhausted, and there's no way you can see opportunities. But I was doing something I loved, and other people were telling me they loved it too, and that's going to be the case if you explore and then do any project you love. Other people will love it too, and maybe you can find opportunities from that, and maybe even make a living from that. So I want to encourage all of you to, just check out that as a possibility. You don't have to have a stupid job you don't like. You don't. You can if you want to. It's up to you. So anyways, what I'm going to teach you here today, who knows what you'll do with it? That's up to you. Maybe you can do more things with it. Maybe it'll lead to something that you love, and maybe you can make a living from it eventually. Who knows? We're going to learn Arduinos today, which is a fantastically easy way to learn electronics. They were designed for non-geeky artists to be able to learn enough in a very short amount of time to be able to use computer chips. Okay, so TV Be Gone uses a computer chip. These computer chips are called microcontrollers. Microcontrollers are little computers. They do what all computers do. They run programs. But a microcontroller is pretty much a microcontroller. It's a computer that's dedicated to run one program. And a microcontroller is usually running a program that controls electronic parts that are connected to it. That's what microcontrollers usually do. So in this case, there are only 5 parts that are connected to the microcontroller, and there's a program inside that is run with this computer that when you push the button, it controls those 5 parts to turn TVs off and make the world a better place. Okay? That's what TV Be Gone does. And you can use a microcontroller to do all sorts of things. In fact, microcontrollers are in almost everything. There's lots of them in a car. There's at least one in every microwave oven. There's ones in stovetops and ovens otherwise. There's ones in your phone if you have a phone. There's several of them in this projector. There's a few in this computer along with a bigger CPU computer chip. They're in just about everything. So Arduino is a board with a computer chip, a microcontroller, but it doesn't do anything on its own. It's designed to be general purpose. It makes it super easy so that anyone can connect some parts to it, because there's a connector on it, there's connectors on it, and it makes it super easy for anyone, even if you've never programmed before, to program that computer chip so that you can control those parts. And you can do that with free open source software that runs on macOS, Windows, or Linux. Arduino is open source. TV Be Gone is open source. They're both open hardware. That means the plans are online. People are encouraged to use those plans to do whatever they want, including copy it, including make products that they can compete with the original. And the Arduino people, just like me and TV Be Gone, we encourage people to copy it, because the more people that make their own Arduino copies, the more people will have Arduinos, and the more people will make projects for Arduinos, so that more people will want Arduinos. Right now, there's well over 100,000 projects for Arduinos online. You can make all sorts of things with Arduino. You can make something that just blinks lights. You can make something that makes noise. You can make something that's a flyer controller, like all those quadricopters we've been seeing at BulkCon. Those were originally made with Arduinos. You can also make robot controllers. You can make things that feed kitty cats automatically. You can make things that tell you when your plants or your garden needs fertilizer, or automatically gives water or fertilizer to plants. All these projects are online. There's even a project for tweeting whenever your toilet flushes. Anything you can imagine, there's probably a project already online that you can use for Arduino. And if you just know a little bit about electronics, and how to solder, and how to use a solderless breadboard, then you can do any of these projects, and you can alter some of those projects for your own purposes. That's what hacking is all about. So I'm gonna go over all of these things today, so that you can download just about any project online and make it. And you can hack them for your own purposes. So this is what we're going to go over. I'll start off with a lecture, and I'll go over everything you need to know about electronics. Everything. You don't need to have a 4-year degree, okay? And then we'll learn to solder, because soldering is an amazingly useful thing to know, and it's also very easy. I've taught tens of thousands of people how to solder in the world. And 3 years old on up. So no matter how hard you might believe it is, you're wrong. It's easy. And it's fun. Look, it says so. I wrote a comic book. It's open source also, and you can download it, and it's open source. People have made it into lots of different languages. Including Chinese and Lithuanian. I don't think anyone's put it into Serbian yet. Anyone want to do that? So, but yeah, it's even in Morse code. So it's 8 pages of soldering wonderfulness. So we'll learn to solder, and then you can make, I'll show you how to make the kit you have. That's the kit in the silver bag, which is made by Evil Mad Scientist. That's a company that makes all sorts of cool kits, and it's a family They make a living making and selling cool kits, doing what they love. And it's called Diavolino. Unlike the original Arduino, it has flames printed on the board. So, but unlike the original Arduino, it does not have a USB controller chip on the board. Because those USB controller chips are expensive. The only reason they're on the board is so that you can program the microcontroller. And if you're going to dedicate your Arduino to a project, once you debug it and program the microcontroller, that expensive $10 USB controller chip is wasted. So almost all, I think all, Arduino copies, and those copies are called clones. Almost all Arduino clones do not have a USB controller chip on them. And so you need an FTDI cable. So I have some of those that you can use for free today. But you can buy them lots of places. I have some also if you want to buy one later for 15 euros or 1700 dinar. So yeah, so that's kind of the trade-off with the clones. But this is a really nice Arduino. So we'll make those. And after you do that, I'll show you how to set up the Arduino software, the free open source Arduino software that runs on Windows, macOS, or Linux. And it's super easy. And then I'll show you how to hack Arduino programs. The Arduino people, they thought that if they use scary electronic and computer science words, that people would be intimidated. Words like program. That's kind of a scary word, they thought. I think it's silly, but they don't call them programs on Arduino, they call them sketches. That's what artists make, right? So programs, how to hack Arduino programs, how to hack Arduino sketches. And then I'll show you how to use a solderless breadboard. Solderless breadboard is one of these. And you can put parts on them, and you can even wire up things from a schematic. Now, the first time you see a schematic, it looks scary. Are people scared? So if this looks scary to you, don't worry about it. I'll show you that it's actually very easy to be able to make circuits from this. And once you can read a schematic, you can wire up a TV Begone from it, and then you'll be able to turn off TVs and make the world a better place everywhere you go. Okay? And if you can make a TV Begone, like I said, you can make anything with Arduino. Arduino is super powerful. You can do so many cool things with it. TV Begone is super simple. It's wonderful, but it's super simple, and it's a great way to learn, and I love pushing my agenda with it. So, and you're a captive audience, so I can do that. Great, so any questions on what an Arduino is, or what we're going to go over today? Yeah. What's that? Question? Cool. Well, if you have a question as I go along, please be sure to stop me, because if you have a question or you're wondering something, you're probably not the only one. So please ask questions as I go along. Okay? So we're going to start off with everything you need to know about electronics. Here we go. So this is a TV Begone. I don't have these anymore. I made 20,000 of them, but they're gone. But this is the pro version, because sometimes you need a professional, and this turns TVs off 100 meters away. I also have a kit that's still available, and that turns off TVs from 50 meters away. But anyways, this is not a phone. Some people think it looks like one. I'm not sure why. I designed the case myself and the sticker, but it's a TV Begone. It turns TVs off in public places. So when you push the button, can you see the little red light blinking? Can you see it back there? It's kind of bright here, I don't know. There's a little light right here that's blinking. So let me just take an aside, show you how TV Begone works, because we're going to learn electronics with this. So all of these on the sticker here, these are just stickers. That's not a button. The only real button is this one down here. When you push that, the microcontroller is programmed to start transmitting TV off codes. Okay? A TV off code is just infrared invisible light blinking on and off and on and off at just the right intervals to be determined to be an off code for, say, a Sony TV, which is different than the intervals that are on and off and on and off for infrared for a Panasonic TV, or a Philips, or a Samsung, or an LG, et cetera, et cetera, et cetera. There are lots and 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 lots of TVs in the world, and they're all on, and they need to be off. But for some reason, they're all on. So it's up to us to turn them off. And there are a lot of codes to do that, and they're all different. And it took me 1.5 years to get those codes, but now they're all open source, so anyone can download them and use them to turn TVs off or whatever they want, because it's open source. Open source is great. So, but all of them are programmed in the microcontroller to control infrared LEDs to blink on and off at the rate first for a Sony TV, so it turns all the Sonys off, and then for a Philips TV, so it turns all the Philips off, and then all the Panasonic TVs, and all the Samsungs and LGs, and et cetera, et cetera, et cetera. It takes about a minute to go through all of those off codes. And by the way, this is the way all remote controls work. All remote controls blink infrared LEDs on and off and on and off to be just the right intervals to control the TV. Unfortunately, those other kinds of remote controls have all of these totally useless buttons that you don't need when you have a TV, like channel up, volume down. Because when you have a TV, the only button you need is the off button. And so that's the only one I have here. It's just that when I push it, that little red light, just like little red lights on other remote controls, or different color visible light, blinks when it's working because we can't see the infrared. The infrared shines out of here. Can anyone see it? Yeah, you can see it with a camera. If it's not a good camera, because good cameras usually filter out infrared, but I have a camera here which is not so good. It's a camera, and if I do this, can you see it blinking? Because cameras, unlike our eyes, don't filter out infrared. But you can see it's blinking, it's blinking, it's blinking. There are a lot of codes, so there's like 150 of them. It takes a minute to do all of them. And we can't see it, so just to let us know that it's working, there's a little invisible light here. Oops, turn off my phone. To show you that it's working, okay? So TV on, the way it works, you push the button, it blinks the little visible light, and then it puts out the off code with the invisible infrared light for Sony. Then it blinks the visible light, and then it puts out the off code for Philips. Then it blinks the visible light, and it puts out the off code for Samsung. Then it blinks the visible light, and then it does the off code for LG. And then et cetera, et cetera, et cetera. It takes about a minute to do all of them, and then it just puts itself into a low power mode, waiting for you to push the button again so that you can turn TVs off and make the world a better place again. So the microcontroller has all of these pins, okay, and I think it's 28 actually. So they're numbered 1 through 28. Pin 1 is this black circle in the corner. And then they're numbered 1 through 14, 15, 16, 17, and 28 over here. Or is it 1 through 20 and up to 40? Whatever it is, that's the way they're numbered. Okay, 2 of the pins are for power and ground. So 2 of the pins are for power and ground. And you can find which pins from the data sheet. The data sheet, by the way, for the microcontroller is 225 pages. It's fun reading if you're ever tired and can't go to sleep. But you don't have to read the data sheet. Projects that are online, people have already dealt with all of that, so you can just follow what other people have done. If you want to start learning more and more, do some projects, and then you can start reading data sheets and learn more. But for now, let's not worry about that. But the data sheet shows you which pins do what. So if you take the power pin, the ground pin, and hook it to the black wire, and the power pin and hook it to the red wire, and then put batteries in here and turn the switch on, then the computer's on and it's doing what all computers do, which is running a program. And the program is in its memory and it's built into the chip. But we can't tell it's doing anything because all that program is doing is controlling pins, which may, if it's going to do anything useful, we need parts connected to those pins. There's no parts connected to this. When a computer chip, a microcontroller, is brand new, there's no program in its memory. We've got to get a program in its memory for it to run when we turn it on. But right now, let's just assume that a program is in there. And in fact, all of these are pre-programmed. They're pre-programmed with a blink program. So how many people here are software geeks? A lot of software geeks. I'm a software geek too. I'm also a hardware geek. But software geeks all know that the first thing you do when you put a new programming language on your computer is type the words "Hello World" on your screen. And if you can type "Hello World" on your screen, then you know you can do anything, right? It might be more complicated, but you know you can do it if you learn enough. The equivalent of that in microcontrollers and hardware is making an LED blink. Okay, that's the hello world of microcontrollers, making an LED blink. So in order to make an LED blink, we write a program and we connect parts to the pins so that the program can control those parts so that an LED blinks when we turn it on. And that's what hello world will be. So in your kit is a little switch. If I take that switch and connect it to pin 3, and then the other side to ground, when I push the switch, it connects the two pieces of metal together. One side's connected to pin 3, the other side's connected to ground, so that pin 3 will be connected to ground when I'm pushing it. When I let go, by default, it automatically just makes that pin high. So in my program, I can have a little loop that says, hey, look at pin 3. Is it high or is it low? If it's high, that means no one's pushing the button. If it's low, that means someone's pushing the button, so I can do something cool. But in my program, what I do is I say, yo, look at pin 3. Is it high or is it low? And if it's high, then no one pushed the button, so we don't do anything. So I look at the pin 3 again. Is it high or is it low? And if it's high, no one's pushing the buttons, so we don't do anything. So we look at the pin again. Is it high or is it low? If it's high, no one's pushing the button, so we don't do anything. So with TV gone, it's pretty much just hello world, except I have a visible light on pin 2. I can have an invisible light on pin 13, say, an infrared light. And when someone pushes the button, it blinks the visible light, and then it pulses the invisible light on pin 13 on and off and on and off in just the right way to be a off code for a Sony TV. And then I can blink the visible light after we're done with Sony, and then blink the invisible infrared light on and off and on and off just the right way to turn off Philips TVs. And then Samsung and LG and Fujitsu and Toshiba and et cetera, until we turn all of them off. And then it goes into a low power state, which just sits there and waits again for someone to push the button to do it again to make the world a better place again. So how many people here are really great at soldering? A few people. Cool. So if you're already fantastic at soldering, then you can go ahead, but just absolutely be sure you ask if you don't know which way a part goes in. Also, I'm here to help everyone finish, but there's only one of me. So if you have a question, please ask, but be patient, but also help each other. because that's what good community is all about, is people helping each other. And if one person tells everyone to do something wrong, then we all get to learn to debug. Okay? Okay? So, but if you've never soldered before in your entire life, or if you're not very confident, please pay attention to what I'll do. All you need in order to solder really well and have a lifetime of satisfying soldering is to see someone who solders well show you one connection once. So I'll show you that with some pretty pictures, and then you'll be set for soldering. So there's a bit of background information so that you know why we solder the way we do, and so that the one solder connection that you'll see makes sense, and then you'll be set for life, okay? Soldering really is easy, and you'll see after I show you this. So let me, okay, so with your soldering irons plugged in, it'll heat up to 350 degrees, and I'll say more about that in a bit. So take your big resistor, the big resistor with brown, black, red, the big resistor, and this is where it goes. Take a look at the shape of the resistor. It's sort of like a rectangle. So on the board where it goes is a red rectangle, and there's a lot of silver circles. They don't have to be a circle, silver areas, and on this kit they all have holes in the middle. So these silver areas are where we solder to. Those are called in English pads, landing pads for parts. Okay? So what we do is we bend the leads of our part first, and then insert it where that part goes. In this case, it's the big resistor 1K, and if you look on your board, you'll see a red rectangle that's written in black letters 1K, and it goes right there. Can everyone see that? And when it's correct, the part is touching the board, and when you let go, the wires bent halfway out won't let it fall out while you solder. You don't want to bend the leads all the way down, only halfway down. See, they're like this. You don't want to have it like this, because if you do that, then at the end, it's hard to cut the excess leads off. So just halfway out is what you want to do. And then you lay it on the table. You lay it on the table and it's ready to solder. But before you start soldering, I got to show you some background stuff first. So don't start soldering yet, unless you're already super confident at all this stuff. And I mean super confident, okay? So, so you need to know 3 safety tips so that soldering is also safe as well as easy and fun and useful. And you need to know 2 secrets of good soldering. So when you first learn soldering on your own, you probably won't figure out these 2 secrets until later, and that's a lot of trial and error that I'll save you a lot of grief by knowing these 2 secrets of good soldering. Okay, so the first safety tip, the soldering iron gets to be 350 degrees Celsius. So if you touch any of the metal part in front of the handle, you will let go very quickly. That's because it'll hurt, and it will. And that's what pain is for, is so that you let go quickly so you don't get burned badly. All right? And, but if you solder, you'll burn yourself. There's just no way around it. Try not to do it, though, because it hurts. Okay? Safety tip number 2. The kind of solder that we have is perfect for soldering electronics. It's made with 60% tin, 40% lead, and it has a chemical in the middle. Generically, the chemical inside of solder is called flux. The flux in this kind is called rosin core, and that's made with mostly sap from a pine tree. All right? So that's called rosin core, and that's perfect for soldering electronics. There's all sorts of different kinds of solder for doing different things, like solder with silver in it is good for jewelry. Solder with acid core flux is good for soldering pipes together for, like water in pipes in plumbing. There's also solder without lead, because lead is poisonous, but the flux for that is very poisonous. So what we want to use, since we're not robots and doing mass production, we want solder with lead. But lead is poisonous. It rubs off very easily on anything it touches. Like if you wrapped it around your fingers 3 times, there's lead on your fingers now. It rubs off very easily. It's not a problem on your fingers at all. It doesn't absorb through your skin. But if you touch food, now it's on your food. That's not a problem either unless you eat the food. But once you eat the food, then it's in your body. It's only a teeny little bit of lead. Lead in your body isn't a problem, but anytime lead is in your body, it goes to your brain and it stays there. Fortunately, a little bit of lead in your brain isn't a problem. Unfortunately, there's already a little bit of lead in your brain because it used to be in all petrol. It used to be in all paint, like for walls. It's in our environment, so we've breathed it in, it goes to our brain, it's there. We don't want to add any more. A little bit isn't a problem, but a little bit more probably isn't a problem either. But a little bit more, that's not a problem either. But a little bit more, well, that's not a problem either. But eventually you reach a threshold where there's enough lead in your brain or any other heavy metal where your brain chemistry stops working, you go insane, people won't like you anymore, you lose your friends. So if you want to keep your friends, wash your hands after soldering and before you eat. It washes off very easily for the same reason it gets on your hands really easily, okay? So please, please, please remember, wash your hands after soldering and before you eat. Okay, so those are the first 2 safety tips. The third and last safety tip comes when we cut the excess wire off, which comes up really shortly, okay? So, so to hold a soldering iron. So if you draw and write with your right hand, use these 2 fingers in your right hand. If you draw and write with your left hand, use these 2 fingers in your left hand, and you hold it like this, just with your main hand. I'm right-handed, so I'll hold it with my right hand. It will get a little bit warm here, but it will definitely not get hot enough to hurt you. So you can always hold it there. And then with your other hand, keep the solder coiled so it doesn't get in the way. With your other hand, use the same 2 fingers and have about 2.5, 3 centimeters sticking out. Now, solder is flexible, so if it's bent in a weird way, just straighten it out so it's sticking straight out. Like this. Okay, and then we're ready to solder. And to solder, you lay the board on the table and you can rotate it any way you like. Oh, but I forgot the first secret of good soldering. So take a look at your soldering iron tip. Grab your soldering iron the way I showed you with your correct hand and look at the tip. Look at what color it is. What color is your tip? Yeah, it's sort of silverish, grayish. It might even turn brown and black, or maybe bluish. Any color but shiny silver. Any color but shiny silver is oxides of metals, which get in the way of the flow of heat, and we only solder well if the heat flows well. Oxides get in the way of the flow of heat, so we won't solder well unless we clean that off. So we need to clean the tip before soldering. And to clean the tip, you have to bang solder off the tip first. So you bang lightly here on the table, like this. Okay, and when you do that, you'll see little bits of solder hit the table. Now those silver areas with holes, the pads that we solder to, those connect all the parts together the way they should. Oh, when you bang the solder off, you bang here. Hello? Hello? You bang here on the table. On the table. Not that way, because that's on the floor. There you go. Cool. Okay, so those silver areas, those are pads. They connect the parts together the way they should and not the way they shouldn't. So those little silver blobs of solder that hit the table, if those hit the board instead, they can connect two pads together, and that's a connection we don't want. And you know what happens if there's a connection you don't want? It doesn't work. Okay? And if we don't have a good solder connection, then there is not a connection we do want. And you know what happens then? It doesn't work. So we want to be sure we don't make connections we don't want, and we do want the connections we do want, right? Okay, so we bang the solder off first, and then we clean the tip. And let me show you how to clean the tip. You keep this on the table, but I'll just keep it up here for demo purposes. You scrape like this. Push down, sort of hard, but you have to hold the sponge. Everyone isn't looking. Everyone isn't looking. Everyone isn't looking. Everyone's looking. Okay, so you bang the solder off first, not on your computer usually, then push down kind of hard, and everyone isn't looking. Okay, you push down kind of hard, and then scrape, rotate, and scrape again. And that's all it takes is 1, 2, just like this. Everyone look. Everyone look. Okay, everyone isn't looking. Everyone isn't looking. No, you don't. You have to look at me so you know how to do it when you do it. Okay, just 1, 2, like this. 1, rotate, 2. And that's really fast. All right? That's all there is to it. And then the tip is shiny silver. But if you take a look at the tip, it starts turning brown and gray rather quickly because chemistry happens really fast at 350 degrees C, including oxidation. So the first secret of good soldering is you must clean the tip before every single solder connection. Okay, so that's always the first step of soldering is clean the tip. And to clean the tip, you bang solder off, and then 1, 2. All right? And it's nice and shiny, ready to solder. Then you can lay the board down on the table and rotate the board so that the leads are straight up and down ahead of you. So I'm on this side of the board, so the leads are straight up and down in front of me. And I lay the soldering iron tip. Don't do this yet. So the soldering iron stand is there for a reason. It's a really good thing because most people tell me that when the soldering iron rolls in their lap, they don't enjoy it. Okay, so keep the soldering iron in your stand when you're not using it. So just watch now, don't follow along. So you lay the tip down across half of the pad. So it's laid down across half the pad, and the tip is actually sticking out a little bit past the pad. It's touching the lead and the pad. And normally we keep it there for 1 second to heat up the pad and the lead. Okay? So, and see the soldering iron is sort of horizontal. It's not like pointing down, and it's not just pointing to the pad. It's actually laid across the entire right half of the pad, or the top, and then leaving this half uncovered. So we're going to feed solder in over this uncovered half, and I'm going to feed the solder in so it hits right here. Not here, not here, and not above the top of the tip, and not even like right here. I want to do it underneath the tip so it melts on the pad and flows around the pad, surrounding the lead, which will make a good physical and electrical connection. All right? So when I feed the solder in, I actually want to scrape along the board horizontally, not coming down like this, but scraping along the board so it hits right there, right where the hot soldering iron tip touches the pad, touches the lead. And not into the lead either, but right here where all three meet. Okay? Like this. Oops, wrong one. You can see the solder scraping along the board going towards that spot that I showed you. And then here it is actually hitting that spot, and you can see some smoke going off. And then you push in about 1 or 2 or 3 millimeters. You know, like maybe this much. Okay? And if you do too much or too little, it's no good, but it's super easy to fix either way. So don't worry about it. Just push in about 1 or 2 or 3 millimeters and then pull away. But this is the second secret of good soldering. When you pull the solder away, do not lift the soldering iron up. Because if you lift the soldering iron up and the solder at the same time, the solder does not have time to flow. The only way we're going to have a good connection is if the solder has time to flow all the way around the pad surrounding the lead to make a good physical and electrical connection. Okay? So keep the tip down to keep the melted metal melted so it has time to flow for 1 more second, and then lift. Okay? And a perfect soldering connection looks like this. It's a little bump, teeny little bump. Okay? If it's not a bump, or if you can see any of the pad, you want to make sure the entire pad is covered, or if you can see an indentation where the hole is, any of that, if it's not a bump or if it's flat or you can see the hole or you can see some of the pad, there's not enough solder. And that means there's not a good connection where you want one, which means it won't work. If that happens, it's super easy to fix. Just add more solder. Just start over as if you're from the beginning. What's the first step of soldering? What? Clean the tip. Okay, you clean the tip, bang some solder off, and then wipe it on the sponge, and lay the tip down across half of the pad, and then push solder in under the tip, pull away, and very important, remember, do not lift the soldering iron tip up until 1 second after you pull the solder away, and then lift. And then it should be a bump. Okay, and then do all of the leads to all of the pads. And then we have to cut the leads short. Because if you don't cut the leads short, these leads will bend over and make connections you don't want. Okay? So
There's too much.
I'll show you that. Oops, what's happening? So if there's too much solder, the blob of solder connects two pads together, and that's a connection we don't want. If that happens, I can help you fix that, but normally what I do is I clean the tip and then scrape lightly between where I don't want solder, and it usually just pulls away with the tip. And then you can bang it off. But if you have any trouble with that, just let me know. I'll help you fix that. So then we have to cut the excess leads. This is the last step. And this includes the last safety tip. So there's a flat side of the wire cutter. There's a flat side of the wire cutter and a deep groove side. The flat side is down, and we cut with just the tip of the wire cutter. But when you squeeze, the wire cutter snaps shut and the lead turns into a missile and hits you in the eye. So last safety tip, see I'm holding the lead as I cut. If the lead is too short to hold and you want to cut it shorter, because even if you have a little bit of wire here, when you cut it, you actually want it to be, where is it? Yeah, when you cut it, you want to cut it at the top of the bump. You don't even want a little bit of wire sticking up. At the top of the bump right here, cut right there. Because if you have a little bit here and then the next part over has a little, they can bend over and make a connection you don't want. Okay? So, so we want to cut it. Why is that happening? Want to cut it right at the top of the bump. And if you want to cut it and it's too short to hold the wire, cover it with your finger and then snip. Okay? So everyone go ahead and do the first part. Oh yeah, and if a part has 28 leads, do all 28 of them and then go to the next part. But if it has 28 of them, like with the microcontroller, all you have to do is bend 2 of the pins halfway out before you turn it over so it won't fall out while you solder. You don't have to do all 28. But you do have to solder all 28. But we're going to start with the big resistor. So go ahead and do that. Let me get that up here. So there's the big resistor. And after you do the big resistor, then you can do the small resistor. And I'll go around making sure everyone is soldering well. And then the Arduino people just used free open source stuff that already existed, but where they did a lot of really great work was by creating lots and lots of examples in order to do lots of cool things. And the examples are under File, Examples, and look at all these categories of examples. But under Basics, and then Blink, let's look at that. Now this is the Hello World program that I explained earlier. Let me make this a little bigger so we can see it. And this is the entire program. How many people here have never programmed ever before? A few people? So you don't need to be able to program in order to understand enough of this in order to hack it. Okay, so let me just show you a few things. This up here, everywhere where it's gray, and there's a bunch of text in gray, these are called comments. Comments are only there for you, the human, reading the text on the screen to understand the program. Those are not things that will be put into the computer's memory that will be run as a program. So a comment is only there as something to tell you, the human, what the program does. A comment in wiring, which is what this is called, but it's really C++, but they call it wiring. A comment starts in one of two ways, either with /*, and then it goes on and on and on until it sees //. Everything in between those is comments. And the comments here tell you the name of the program and what the program does. So if any of you here are a software geek, you know that you have to do that at the beginning of every program. Otherwise, I take your software geek card away. Because no matter how simple a program is, you have to have a comment at the beginning that reminds you what the program does and what it's called.
What if the first line says this program doesn't have comments? Okay, there goes my car again.
So another way to have a comment is like here, / and everything to the right is a comment, and it usually is there to tell you what the statement in the program does. And if you've never programmed before, these program statements look really bizarre and kind of inexplicable. But all you have to do is read the comment that whoever programmed this and put it in the examples, they put that there so that people can learn from it. So remember what the Hello World program does. It only does a little bit. It says, make pin 13 an output pin. Then make pin 13 high, which turns the LED on, and then make pin 13 low, which turns the LED off. And that's pretty much all it does, except remember we have to have a delay in between, otherwise the computer going at 16 million times a second is going to turn the LED on and off too fast to see. So we turn the LED on by making the output pin high, keep it high for a second, and then make it low, turning the LED off. And then we keep it low for a second, and then in this program we repeat over and over again. Okay? So another weird thing with programming is we can, let me highlight that, we can have what's called as a definition. Okay? And that's done so that people reading your program have an easier time of it. Or if you 3 weeks later, after writing your program, come back to it and want to figure out what you were thinking about and what your program does, it makes it easier on you too. So this line here, it says int LED equals 13. That just means whenever later in the program, further down, anytime you see the letter combination LED, replace that with the number 13. Okay, so for instance, here it says LED. Just replace that with the number 13 in your mind, because that's what the Arduino software is going to do. Okay, so Arduino software, Arduino programs all have two sections. The first section is called setup, and that's this section here. And the second section is called loop, and that's this section here. Setup, most people who are programmers would not call that setup, they would call it init, or initialize, or initialization. But that sounds too computer sciencey, so they call it setup. And that is done once when you turn your computer on with the on-off switch here. So that's done once. Everything in setup is done once, and then it goes to this section called loop, which is done over and over and over and over again continually until you turn the power off. Yeah?
But when you press the reset button,
That's the same as turning it off and on again. That's all the reset is. So loop in computer science means something that's done over and over again. And they left that term in, even though it sounds scary and computer sciencey. Okay? So, so that's what happens. So this line right here, pin mode, comma, LED, or parentheses, LED, comma, output, parentheses, semicolon. Okay, that's bizarre, but that makes the LED pin, which we defined up here as pin 13, that makes pin 13 an output pin. Okay? So let's say I wanted to hack this program, and instead of pin 13, I wanted to make pin 2 an output pin. What would I do? Yeah. So I could just come here, and rather than 13, I can just change that to 2. Or I can just come down here and get rid of LED and make that 2. And now pin 2 would be the output pin instead of 13. But let's keep that as 13. But let's say also I want to hack this, and instead of making pin 13 an output pin, I want to make it an input pin. What would I do? Any ideas? Yep, that's it. So that's all you have to do to play with these things. You can hack these to be different for your purposes. Now pin 13 is an input pin. The LED pin is an input pin. But let's leave it as an output pin. So that this setup initializes the pin 13, which is the pin, by the way, that you already soldered the LED to through the big resistor that you soldered on your board, the 1K resistor. Remember, that was the first resistor you soldered on your board? You soldered the LED, the red LED, through the resistor to pin 13 to ground. So this is going to be controlling that LED, turning it on and off. All right? And in order to turn it on and off, all we have to do is make pin 13, our LED pin, high and low. And that's what we do down here in loop. And you can see what the comments here say. Initialize the digital pin as an output. And in this case, it's the LED pin 13 as an output, which down here, we're going to turn it on, wait for a second, turn it off, and wait for a second. The comments tell us this. And this is what the computer, the microcontroller, is actually being told to do. So digital write, parentheses, LED, comma, high, that just makes the LED pin high. Pin 13 is high. Delay 1000 delays 1,000 units of time, and the units here happen to be milliseconds. And a millisecond is a thousandth of a second. So 1,000 thousandths is 1 second. So delay 1 second and then make that, it's the same thing. Digital write LED high, digital write LED low. This makes it low, it turns the LED off, wait a second, and it'll do it over and over again. But this is just text on a screen. It's just text on a screen. It's not what is in the memory of our microcontroller. In order to put it in the memory of the microcontroller so that when I turn it on, it actually runs that program, I've got to connect my FTDI cable to the Diavolino and then press this button here. See, it lights up white and it says upload. If I do that, it will convert this text into a form the microcontroller understands and then send it through the FTDI cable into the microcontroller's memory, where it will then run the program. So let me plug this in the correct way. And when you plug this in, make sure your Diavolino battery is off. Otherwise, the battery voltage might go into your computer and your computer might not like that. Okay? So just have, but when you do that, your Diavolino is now being powered by your computer's power supply. And see the way this is blinking? The way it was blinking when you first built it. This is not the same as the blink program here. Oops. The blink program here is on for a second, off for a second. This one is on for a tenth of a second and off for a second, and then repeats. So if I press this button, it will convert this text into a form the microcontroller understands, send it through the FTDI cable through into the memory of the microcontroller, and then run it. So let's do that, and then it'll start blinking this way instead of this way. So watch what happens. I'll do this. And see there's a progress bar over here. And see over here it says compiling sketch. That's a scary computer science word. Compiling. That means converting to a form the microcontroller understands. Uploading means it's sending the information to memory where it's now there, and look at the way it's blinking now. On for a second and off for a second. Okay, so that's the way you program an Arduino. It's super easy, right? Pretty cool? But let's hack this a little bit. So just because the person who wrote this program intended the LED on pin 13 to blink on for a second and off for a second doesn't mean that that's what we have to do. We can change it. So let's change the blink rate. How about if we make it blink 10 times faster? What do I have to do to make that happen? Yeah, I can make the delay shorter. So I'll make it 10 times shorter. So rather than 1,000, I'll make it 100. And that's actually 1/10 of a second each. So, but again, this is just text on a screen. Changing this text didn't change this. I've got to press that button with the cable connected, and I'll do that. And then you can see the progress bar. It says it's compiling. And once it's done compiling, now it's uploading. And now it says done uploading, and look at the way it's blinking. Cool. Okay, and one other thing, look at this white text down here. It says binary sketch size. That's the size of our program in memory. So 1,084 bytes. Those are bytes, not gigabytes. Okay? And out of a maximum of 30,720. So that's the size of memory we have available. The memory is actually 32 kilobytes, but 2 kilobytes is already used up by something called a bootloader. The bootloader is pre-programmed on all Arduinos, and that is a program that is run when you turn the power on. And what it does is look on this connector and see, it sees if one of your cool programs is coming in or not. If it isn't, then it goes to the program in the rest of memory and runs it. So once this program is in memory, I can unplug it, now it's not working, but if I turn the power on, I can leave it off for years, but when I turn the power on, that program's still in here. So when I turn it on, the bootloader sees there's no program coming in, so it starts executing the program that you put in last, which is this fast blink program. All right, so let me turn that off. I'm going to hack this program a little more. I'm going to put this back to the way it was when we were, before we started hacking on it. So on for 1/10 of a second and off for a second. So here's off for 1/10 of a second, on for 1/10 of a second and off for a second. And then I'll put that in memory by doing this. Uploading. And now it's done, and now it's doing what it was doing when we first finished soldering the Diavolino. Okay? But I have an LED here, and I want to make this LED blink with this Arduino. What do I do? Well, it's really easy. Take a look at the picture here. These connectors connect anything plugged into them to pins of the microcontroller. Okay? Now, this LED is connected through the big resistor to pin 13 of the microcontroller. We soldered all that together. That's on our board already. But I want to make this LED blink using the blink program, which is controlling pin 13. Look over here. See it says D13? That's digital pin 13. And by the way, down here there's A0 through A5. Remember I told you there was digital and analog and computers use digital? Well, this microcontroller actually does have a little bit of analog capability. These are analog input pins. If I put an analog voltage on one of these between here and ground, and then there's instructions that can say, turn that digital or analog voltage into a binary number. And then depending on what those numbers are, you can do various things. So I'm not going to talk about that today, but just so you know, those are there. But D0 through D13, these are digital pins which all can be input or output. Okay? And in our Blink program, we already programmed pin 13 to be an output pin. So if I take this LED, and I put the long lead, the plus lead, into D13, and I take the short lead and put it into ground, right there, ground, then when pin 13 is high, this LED will turn on. And when pin 13 is low, this LED will turn off, just like the one here. So remember, in order to make the LED, my external LED blink, I plugged the long into D13 and the short into ground, and this connector in the board connects that to the microcontroller. The solderless breadboard is pretty much like that, except there are a lot more holes. There's a lot of columns of 5 holes. Now, when you first start looking at a solderless breadboard before you've used it, it can be a bit confusing, but after you play with it a while, something just clicks and it makes sense. That will happen to all of you, I guarantee it, okay? But hang with me for now. There's these columns of 5 holes, and they're numbered just for being able to describe which hole you're using. And so here's column 1 on the bottom. There's also column 1 on the top. Column 1 at the top is separate from the one on the bottom, but these 5 holes are all connected to each other. So if I connect something, if I put anything in here, then it's connected to all these other holes. So if I put something in this hole, a wire of a part in this hole, and a lead of another part in this hole, those 2 parts are connected to each other. You can also just put wires in. Like here's a yellow wire. If I plug this yellow wire in here, and then I put this red wire in here, then the yellow and the red wire are connected to each other. Okay, so that's true of all these 5 holes. The same is true of any column. And the same is true of any column on the top or any column on the bottom. The ones on the top are not connected to the ones on the bottom. And these rows here and these rows here are also separate. These rows marked minus and plus, every hole in this row is connected together. Every hole in this is connected together. But these are not connected to each other. Okay? And the intent of this, you can use it any way you want, but the intent of this is you can connect this to the power, or VCC, your power supply, and then connect this to ground, and then anywhere in your circuit where you need power, you can just plug a wire into here, or a part. Anywhere where you need ground, you can plug it in any of these holes. And you can also do them up here too. But these are not connected to each other automatically. If you want them connected, you have to put a wire in yourself. Okay? So if that doesn't make total sense yet, don't worry about it. When you start playing with it, it will click in your brain and it'll make sense. But you have to play with it a little bit maybe. Okay? So, but let me show you an example. I want to make this LED blink on the board rather than blink on the Diavolino. Let me go back to the Diavolino again. To make it blink on the Diavolino, I put the long lead here, D13, and the short lead here, ground. And then the LED would blink on my board. But I want to make it blink not on the Diavolino board, but on the solderless breadboard. So I just plugged it in to my solderless breadboard. And then I can connect wires from the Diavolino, pin D13 and ground, the same pins I used before. If I take wires from here, D13 to the long lead through a wire to my solderless breadboard, and ground through a wire to the short lead of my LED on the board, then the LED will blink on the board. So here's what I do. Now you don't have all the parts for doing this, but I do, so let me just do this. When you plug a part in the board, you don't know anymore which is the long and the short, you just have to remember. And I arbitrarily plugged it into column 7 at the top and column 6 at the top. It didn't have to be those two. I just happened to do that. And then I have a black wire going to the ground of the Arduino and a red wire in here going to D13 of the Arduino. So D13 comes in here into this hole, which is connected to the long lead of the LED, and ground from the Arduino coming here, which is connected to the short lead of the LED, so it should blink the same as the Arduino is telling it to. Now the schematic probably does look a little bit scary if you've never seen it before, but it really is easy. Everything on this schematic corresponds to a real thing in our real world. And everything in the real world that we need for our circuit corresponds to something on this diagram. So we could, if we were all really good artists, draw the circuit the way it actually is in the world, but that's a pain. We don't really want to have to do that. The best way for anyone who's created a circuit to tell someone else how a circuit works is with a schematic diagram. Because then you can do it really fast and you don't have to be a good artist. And even if you are a good artist, it's still easier to do it this way. So everything on this corresponds to something in the world. For instance, here is a black rectangle that says Arduino in it. What do you suppose that is? It's the Arduino. Okay, and it's very standard in schematics to leave out all of the pins that we don't need, to only show the ones we do need. So in here, we've only got 1, 2, 3, 4, 5 pins that are relevant. Okay? So we've got D3, D2, D13, ground, and VCC. Okay, now take a look at VCC. VCC has this line, and a line in a schematic is just a wire. So VCC goes through a wire to this symbol here, a circle with 4.5 V next to it. So that just means that VCC for our Arduino goes through a wire to 4.5 volts of our power supply. Okay, and whenever you see this circle with 4.5 V next to it, that just means connect it to the red wire of our power supply. But you already did this. You soldered the red wire to the VCC pad of your Diavolino. So that's already done. And let's come down here. GND, that's ground. GND, ground. That's the minus of our power supply, and that's what it has to go through, and it goes through a wire to this symbol, and this symbol is the symbol for ground. Anytime you see it, it just means connect it to the black wire of our power supply, GND. Okay? So you'll see that here, and also for power, that's also over there. Cool, so let's look over here. D2, that's the hole for D2 on your Diavolino on the connector for D2. There's a wire going to this side of this weird symbol. The other side of that symbol has a wire going to what? Ground. So that's whatever this is, one side is connected to D2 and the other side is connected to ground, the minus of our power supply, the black wire. This is a symbol for a switch. Remember what a switch is? Especially a push button switch. It's just two pieces of metal which are either not connected like this or connected. Not connected or connected. So that's why the symbol for switch looks like that. For the symbols, they always try to make it so that it's somehow relevant, either physically like the part or somehow in the abstract like the part. Okay? So that is a switch. And that's the switch that's going to tell the Arduino, once it has the TV Begone software in it, the TV Begone sketch, to start. Okay? Activator switch. Okay, can you see the gray here? This is the LED and the resistor that you already soldered in and connected to pin D13. Okay, so this symbol here, same as that one, is a resistor. Now if I were on a bicycle and riding along this smooth surface and suddenly the surface looked like this, I would slow down. And that's why the resistor looks like this. Okay? And the amount it slows it down is given by the number on the top. And this one's a 47 ohm resistor. This one is a 1,000 ohm resistor. And this is the one you soldered on your board, the big one. And then this is an LED. So is that. Now, an LED is a special kind of diode. Remember what a diode does? It's a one-way valve for electrons, which is why the symbol for a diode looks like an arrow. It shows you the direction the electrons flow. Okay? And there's a plus side and a minus side. Look at this one, it's easier to see. See the bar here? That's kind of like a minus sign. That's the minus side. And then the other side up here is the plus side. So this is the long wire, the plus side, and this is the short wire, the minus side. Now that's the symbol for a diode if it doesn't have these little arrows or lightning bolts coming out. If it has little arrows or lightning bolts coming out, that means that it's emitting something, such as light. So that's an LED, if it has the arrows or lightning bolts. So here's an LED, and you can, I don't know if you can see it well, but the minus side with the minus sign bar here is connected through a wire to ground. The other side goes to one side of the resistor. The other side of the resistor goes to D13. And we don't have to do this because you already soldered that in. And there's only one other little part of the circuit. We have a resistor here, 47 ohms, going to D3. One side going to D3. The other side goes to this pin of this part here. Don't worry about that, what it is yet, but this pin of this part goes through a wire to ground. And this pin of that part goes into one side of this 10 ohm resistor, and the other side of that 10 ohm resistor goes into the minus of this infrared LED. See, infrared LED? And the plus of the infrared LED goes to here. What's this again? VCC, the red of our power supply. This is a transistor. Okay, remember a transistor, it's an amplifier. So whatever comes in gets amplified and goes out. And there are 3 pins, a ground, an input, and an output. The ground, the technical term for that as we use it, is emitter. And that's why it's hard to read here, but that's an E for emitter. And then the input, the technical term is base. So we have a B here. And the output, the technical term is collector, C. And normally on the schematic, it's not written E, B, and C. You just have to know which is which. But you can find out very easily from the data sheet. And the data sheet will show you an actual drawing of the part with the 3 wires coming out to show you which is C, B, and E. Okay, and then since I don't want you to have to memorize the color code today, I showed you what a 10 ohm resistor and a 47 ohm resistor look like. And there's 2 ways of representing with color code, with 4 bands or with 5. We have 4 band resistors today, so that's these 2. Yeah. The long is plus. Okay, and one thing which is kind of confusing, the push button that comes in your bag of 5 parts with my card, the push button has, the schematic symbol for the switch is just shows 2 leads, and yet the part actually has 4. So they come in pairs. So take a look at your part. You can orient it 2 different ways with the push button like this. You can have the 2 leads sticking up and down, or you can have the 2 leads sticking left and right. You want to orient it with the 2 leads sticking up and down. And if you do that, this is the way it corresponds to the schematic symbol. The left side of the switch is either one of these. Internally, these are connected. So you can use either one of these for the left side of the switch. You can use either one of these for the right side of the switch. Okay, because internally these 2 are connected. You can actually also use these 2 or these 2. So play around with that, and it'll make more sense too as you play with it. But believe it or not, you now know enough to wire up a TV Be Gone. And if you want to set up the Arduino software on your computer, go ahead. I have 5 FTDI friend cables that you can use for free. And if anyone wants them, I do have more available for 15 euros or 1,700 dinar. Okay. You can buy them elsewhere, and if you had a hackerspace here, you could just go there and use it for free. So, but you don't, so you have to create a hackerspace here. The next time I come here, you better have one. Cool. So, so go ahead, and I'll just hang out and help you as long as you like, so you can get this working. And then we don't have a TV here to turn off, which is actually a good thing. We do? Yeah? It's remotely controllable? Yeah? What kind is it? Yeah, well, let's try it on that. But we can test it out with any camera, any phone that has a camera, but not an iPhone, because iPhones, even though they're not great phones, they're really good cameras. And good cameras filter out infrared. So, and also some, I think Samsung makes their latest Galaxy filters out infrared too, but the one on my phone is really crummy, so we can test it on mine or many other phones' cameras.